There are some limitations for the academic version of at-risk. These are listed here. These limitations are not there in the commercial versions. If you buy the commercial version, okay, at-risk doesn't have these limitations. So simulation model must be contained in a single workbook with at most 4 worksheets, and each worksheet is limited to 300 rows and 100 columns. That's pretty big. So it's really not that big of a deal. And the number of probability distributions for the input cell, like demand with the triangular distribution and so on. So those kinds of cells, okay, is limited to 100. Now you can go around this limitation by using Excel functions. Okay, when you can. Now there are some probabilities that you cannot generate using other using Excel built-in functions, and you can use at-risk functions for that. But whenever you can use built-in functions, then you can use the built-in functions. So that way you can incorporate more probability input cells. So the number of unattended iterations is limited to 1000, which is what we just saw in the previous example. So every time you have to click, once 1000 iterations have been done, so you have to click OK to proceed further. Now the at-risk graphs will contain the watermark that it is an academic version, and the distribution fitting tool. So if you have data, raw data, you can use the distribution fitting tool to fit what is the most likely probability distribution. And academic version is limited to only 150 observations. Okay. And of course, as I said just a minute ago, these limitations are not there in the commercial version. Okay, now let's look at the distribution fitting functionality of at-risk. So here I have a data set of median income of households, and I have 150 of those. Okay. Remember, this is academic version, so we are limited to only 150 data points. If it is a commercial version, then you can have any number. Now with this data, we want to fit what kind of probability distribution will generate numbers approximately like the data that we have. So you go to distribution fitting, and there are several ways in which you can fit. We'll use the basic one, which is fit. Okay. Now the median income and the range is A2 through A51. Okay. If this doesn't show up automatically, then we can go and highlight the range and click OK, so that will work. All right, now the second tab gives you the distributions that we can try, and at-risk automatically recommends a set of different probability distributions to try on the data. So we'll just accept the recommended distributions, and we can click fit, and at-risk has gone through through all of those different distributions and rank them by the best fit to the worst fit. Okay, we can compare the best fit for the other with the other distributions. Like for example, if you click the last one, you see what the actual value looks like and what the best fit looks like, which is the red line, and what the Levi distribution looks like. Okay. Obviously that's not a good one. So let's compare one more, say normal distribution. So let's compare this to normal distribution. You see, normal distribution will generate values from this distribution, whereas the actual distribution is like that. Okay. So the suggested distribution is Pearson 5. There are 5 or 6 different categories of Pearson distribution. And log normal is probably a easier distribution to use, and it looks like log normal is very close to the best fit. The difference is not a whole lot, so we could probably use the log normal distribution. whichever distribution you want to use. So suppose we want to use log normal distribution, and you see the parameters here, or this is the mean, standard deviation. Okay, so you can look at the log normal, mean, and standard deviation is right here. Okay, and this is the converted value, and then the risk shift is 1631, so that is it shifted to the minimum value. So we can either copy paste this, or we can write this to a cell. We can write the function to a cell and then copy paste it. So write to a cell, and we want the log normal one. Okay, now we can say we want to put that in cell, say D1. Okay, so then the function name is right here. So the risk name of the function is median income. We really don't need that part. So this is the part that we need. So this, remember, this is the minimum value, and these are the, this is the standard deviation. This is the log normal value of the mean. So we can set this up in different cells and use it in the defined distribution. So very easy to, if you have a set of data, it's very easy to fit the best fit probability distribution using the distribution fitting tool of @RISK.